Yeah,
Good, how are you?
fine. Okay, I got this. It's amazing how the weather changed, huh? I was
Oh, I know, it's like day and
canceling.
night.
I was canceling appointments 2 hours ago, and then all of a sudden it's golfing weather out.
I know.
Well, anyway, I'm glad ours was online, so it didn't get affected. Um, all right, let's take a look at these exercises. You want to just start on one?
Yeah.
Okay. Before we start on one, let's do the easier one and do number 3,
Okay.
just to demonstrate the principle. How do I do number 3?
Um, so you have to combine, because they have the same, denominator.
Since they have the same denominator, we can go ahead and do this subtraction and operate on the numerator.
Oh, okay.
Okay? Because we don't have to change the common denominator. The common denominator is going to be that.
Mm-hmm.
And the new numerator is going to be, just for clarification, let's put parentheses around everything because it really matters here. Don't need the first set of parentheses, but I do need the second set. Notice that the sign on the negative 3y changes as long as I use parentheses here. And I have to use parentheses, but if I don't use them, I could end up getting the wrong sign on both of this. So what's the new numerator going to be? After I perform this operation,
X minus y.
keep going.
X minus y minus x plus 3y.
Okay, so the x's cancel. And you have minus y plus 3y, which is what? What's this? Minus y plus 3y?
2y.
All over 6x squared y squared. Now how can I reduce it more?
Just divide the 2, so y over 3 x squared y squared.
Okay, and then I can do something with that y also. You're right there, but I can simplify it further because this is a y and this is a y squared.
Oh, can you subtract, subtract the y?
Well, y divided by y squared is equal to 1 over y. In other words, I can divide top and bottom by y. When I divide top by y, I get 1. When I divide bottom by y, I get y to the 1th.
Okay.
So this simplifies to 1 in the numerator and just y in the denominator. So that's number 3, the answer for number 3. Now let's go back and do number 1. Now that we know how to add and subtract fractions, we know that they have to have the same denominator. So, whoops, my mind saw V and my brain wrote 4. How do I subtract these two fractions?
You have to first find a common denominator.
Okay, what's that going to be?
I don't really know.
Always,
I don't know, I'm confused.
when there's variables involved, just think that it's going to be the product of the two.
Okay.
Okay, so the common denominator, this has to be a common denominator. And the reason it has to be a common denominator is because both of our denominators divide into this evenly.
Okay.
So this is our common denominator, and just always assume that. You can find a common denominator by multiplying them together. That's the truth. won't always be the lowest common denominator, but it'll always be a common denominator. And in this sense, in this problem here, it's the lowest common denominator.
Okay.
Okay? So what goes on the left? If my new common denominator is this, what goes on the top left?
6, and then v plus 2.
Not v plus 2.
Just v minus 5.
5, right. The reason is that in order to convert that, to give me that new denominator, I had to multiply it by v minus 5 over v minus 5, or the number 1.
Okay.
Okay, I can multiply any fraction by the number 1 without changing its value. So this particular fraction I multiplied by v minus 5 divided by v minus 5. That gave me the desired denominator that I want, and it left me with this in the numerator. So how about the other fraction?
So 2v plus 2?
Yeah. Now let's simplify. Now we've got a common denominator. And I don't put these together because there's no real need to multiply them together. In fact, it's better to give them in a factored form like this than it is to actually give them multiplied together. So what do I have upper left now?
Oh, 6 v minus 5.
Minus 30, because I got to distribute the 6.
Oh, right.
I got to distribute the 6 to both. And then the only thing I have to be careful about doing that is that I put parentheses around it. Because there aren't any parentheses there to begin with. Notice there were no parentheses around that 2. Okay, and the only mistake you can make on these problems is to not put parentheses around it. So what goes in the parentheses?
2v plus 4.
Exactly. Now let's simplify the new numerator.
Okay, so
how many v's do we have?
oh, sorry. 4v
How many numbers do we have?
minus 34.
Yeah. And that's our answer. That's fully, ooh, wow, ooh. It's like my, all of a sudden it happens every now and then, my mouse and my cursor get confused with one another, and it just starts drawing all over the place. Let me close this page out. Well, before I close it out, can you see what the, no you can't.
Yeah, I know what the answer.
Okay. Well, I'm going to have to close this page out and open it up again. I've had my thing go crazy before, but not like that. That was weird. Okay, let's see. Let's look at number 2. So in this case, we have 2x over 8 minus 2x over x plus 8. What's the common denominator going to be?
X plus 8.
Times 8.
Okay.
And it's the product. The
Okay.
product of the two. So I have to have an 8 times an x plus 8 as my common denominator. What goes upper left?
2x time or 8, and then in parentheses, x plus 8.
Just x plus 8
Okay.
with the 2x. Because again, in order to give this term, this denominator, what did I have to do to it? This is so important you can't imagine, for adding and subtracting fractions that have variables in them. You need to understand this concept. How do we convert this to this?
By finding, I don't know.
By multiplying top and bottom by x plus 8.
Oh, okay.
This is always the same process. So it's what you do whenever you multiply, add or subtract fractions, is you find a common denominator, and to find the new numerator, you have to figure out what you did to that fraction to give it that denominator.
Okay.
Okay, on the right, what do I have?
2x, the same thing.
Times what?
Yeah. Oh, times x plus 8?
No. I don't have to multiply this denominator by x plus 8 to give it the new denominator. What do I have to multiply it by?
8?
8 only. 8 over 8. So what I did was I multiplied this by 8 divided by 8, the number 1. That gives it the denominator that I desire, and gives it this new numerator. So now let's simplify the numerator. We know the denominator doesn't change. It's 8 times x plus 8. What's the new numerator become?
Is it 2x squared plus 16x minus 16x? Okay,
so it's 2x squared. Now I can simplify it more. Hi, come here. Come here. So I can divide top and bottom by 2 to change this to x squared over 4 times x plus 8. And there's nothing further I can do to simplify it. I cannot, in other words, even if I distribute this 4, I end up with x squared over 4x plus 32. Maybe somebody likes that answer better, but I can't simplify it any further. Cannot do anything with the x squared and the 4x. The reason is there's this 32 being added to the 4x. Once you add a number to the variable, you can't any longer cancel it out with that x. All right. We've done 3. 4 is kind of similar to 3. What's the answer on 4? At least what's the next step?
Is it just negative 1n over 36m?
Okay, make sure you do not make that mistake. Here's what you did. Right? You didn't put the parentheses in. Those parentheses change everything. Notice that this now becomes a plus 4n. So we have 7n in the top and 36m to the 4th in the bottom, and that's our final answer. But this 3n minus the minus gives you plus 4n or 7n. But notice the difference if I leave off those parentheses. Now it did become minus n instead of 7n. So the key here is just to remember that when you're subtracting two fractions like this, the best thing you could do is put the parentheses in immediately.
Okay,
and that way you will not make that mistake. And trust me, that is a mistake everybody makes on that problem. Okay, now number number 5, it's a little different. Usually when you see a quadratic in the bottom, it means you need to factor it.
You're right.
Let me look at this for a second. Trying to figure out why this problem is on your exam. This might need, hold on. Well, let's factor this thing as much as we can. I'm going to pull out a 2, leaving behind 4x squared plus 7x minus 15. Now, at this point, I got to think, well, can I factor this further? And yes, you can. Let's go ahead and factor it further. It's a quadratic. It might factor. And if we're lucky, one of those factors might be x plus 6. Although I can see that that's not the case. In fact, let me think here for a second. 15 times 1 and 1 times 4 doesn't give you that. 5 and 3. How does this factor? Let's try this. Plus 5 minus 3 gives us 10x minus 6x. That doesn't work. If this was 4x and x, this works. Only it works like this. 4x and x, and we need a plus sign, so this has got to be plus and this has got to be minus. Notice that this gives me minus 5x. This gives me plus 12x. Add those two together, I get my middle term, which is the one that I'm looking for. So that factors like that. So let's erase this with that factor. And then this, 4x over 2, okay, so what's our common denominator?
4x minus 5 and x plus 3.
Times 2. Yeah, in other words, I can't just use 4x minus 5 and x plus 3 because this whole term does not divide evenly into that. But I can use the whole term. Here's my common denominator. I'm going to leave it in factored form in case something nice happens with that x plus 6. I don't know what it would be, but in other words, that's my same common denominator. I don't need to multiply 2 times that. In other words, 2 divides evenly into that. So this is my common denominator for both terms. And first of all, do you see why that is? In other words, why I do not have to multiply. I could have multiplied 2 by that, and I would have had a 4 here, and 4 would have been fine as a common denominator. It's just bigger than I need. You always kind of want to use your lowest common denominator. Okay, so on the left side, what's in the numerator?
So is it x plus 6?
Okay, and on the
then
right side, what's the, what did I have to do to the right side?
Just
How did I turn this into this?
just multiplied it by 2, 4x minus 5, and x plus 3.
Not by all of it, just the 4x minus 5 and the x plus 3. I don't have to multiply by 2. There's already a 2 there. So I had to multiply it by 4x minus 5 times x plus 3 over 4x minus 5 times x plus 3. This concept that I can't stress often enough, where you can multiply any fraction you want by 1. This is 1. That is equal to 1. And it gives me the desired denominator. So we do need to simplify. So let's go ahead and multiply 4x times these. What do I get?
So
16x squared.
16x squared minus 20x plus 4x squared.
All times x plus 3.
Oh.
In other words, all I did was multiplied those two together to get this.
Okay.
And then that product still needs to be multiplied by the x plus 3. Okay. Now, can we do anything? To simplify that? Well, we've got a common denominator. So let's simplify the numerator, and I do have to distribute this now.
Okay.
The reason I do is because it's going to give me some number of x. In other words, at a minimum, it's going to give me minus 60x after I multiply. And I'm going to be able to combine that minus 60x with this single x over there. So I don't want to leave this unmultiplied, undistributed.
Okay.
So I've got x plus 6 plus, and I'll put parentheses just for clarification here. So we need to FOIL these two binomials.
Okay.
So can you FOIL? Go ahead.
16x cubed plus
48.
48, yeah. X squared.
Okay.
Minus 20x squared minus 60x.
Now you see why I needed the parenthesis. Okay, even though because this is a plus sign, I can now get rid of the whole parentheses. If this was a negative sign, like it was in some of our previous problems, I would need those parentheses. But if it's a plus sign, I can just drop the parentheses and use the sign of each term. So let's combine. Let's start with how many x cubes we have. How many x squareds do we have?
64.
Actually, we have 48x squareds minus 20x squared.
Oh, minus, sorry for this.
So that's 28.
28.
Total. How many x's do we have?
59.
Okay. And how many numbers do we have?
6.
Okay. And then that's all over. And not really any need to distribute this on the bottom. Only reason I distributed it on the top, I foiled it, was because I knew I was going to be able to simplify that 60x with this single x, which I did. But now that I get this, that's a perfectly fine answer. And I can't divide top and bottom by 2 because I have an odd number right there. So I can't really simplify that any further. That's my
Wait, how come up above you didn't just cross out the x plus 3? Is that because there's one on...
I needed the one on the bottom because I can't add these two fractions. The only way I can add this fraction and this fraction is if I have the same denominator.
Oh, okay.
So if I cross out the x plus 3 and this x plus 3, I no longer have that denominator I'm looking for.
Okay.
So I didn't want to do it. In fact, what I did was multiplied it by x plus 3 over x plus 3 to get there in the first place. But I've simplified the numerator, and this is my final answer. Even though I obviously have some number of x squared in the denominator, if I were to FOIL these two together, I would have a quadratic, and I could list it as a quadratic, but it wouldn't help me simplify it any. No way I can simplify this quadratic with this cubic.
Okay.
Okay, so there's nothing wrong with this as a final answer. Okay, now this one, a lot of people have a hard time dealing with adding a fraction to a whole number. Don't get confused by that 3k. Put a 1 under it.
Okay.
By putting a 1 under it, I mean we're going to do that, and now it's easier to visualize what the answer is going to be. It might seem like I could factor the bottom. I'm curious they keep giving you these problems because I can see that I could maybe factor the bottom, but the factors are going to be k plus or minus something times 3k plus or minus something. And neither of those factors are going to be able to cancel out with that factor right there or this factor right here. In other words, neither this cannot possibly factor into one of these two things because 3k squared has to start with 3k and k. There's no 2k there. So there's no way I'm going to be able to do anything with it, even if it factored. So I'm not going to give it much attention. I'm not going to try to factor this quadratic in the bottom. I'm just going to go ahead and operate as if we have another fraction over here. What's our new common denominator?
3k squared minus 6k minus 45.
Right. So I want that to be over here. So I've got to multiply this right fraction by what?
3k squared minus 6k minus 45.
Over. Remember, I can only multiply it by 1. If I multiply it by any other number other than 1, I've changed its value. And I don't want to change its value.
Right.
So all I want to do is simplify it. So I have to multiply it by that over that. And that gives me the common denominator that I'm looking for in the bottom. Okay? Now let's simplify the numerator. So here's my new common denominator for the whole thing. I've got this 2k minus 3 up here. I'm going to put parentheses around it for clarification. what do I have on the right side now?
Is it 9k cubed minus 18k squared, and then minus 135.
Okay. Okay. Now let's simplify the numerator in order.
Sorry. So is it?
Let's put them in order with
3.
yes. So we're going to put it in order of the size of the exponent. We want the highest exponent first. Want that term right there first. That's the only amount of k cubes that we have. How many k squareds do we have?
Minus 18k squared.
How many k's do we have?
133.
And how many numbers do we have?
Minus 3.
There's our answer.
Okay.
Now, there is a possibility. Let's see, 133 is not divisible by anything, so I can't factor any number out from up here. Looked like I could factor 3 out, but 133 is not divisible by 3, so I can't. One has to ask themselves the question at this point. This is a cubic function, and it could certainly factor. And it's possible it could even factor where one of its factors might be what we have in the denominator here. But it's almost impossible to tell without a great deal of effort. First of all, factoring cubic functions is a whole lot different than factoring quadratics. Quadratics, you always can use the quadratic formula to factor a quadratic 100% of the time. There's no equivalent formula for cubics. To factor a cubic really requires an unbelievable amount of trial and error type effort. So it's hard for me to believe that they want you to do that. So I would tend to give this as a final answer.
Okay.
In fact, I'm a little surprised by these problems, to be honest. They're a little different than I'm used to seeing because they have these wild answers that don't factor. Okay, so what do I have to do to this problem before I can proceed? I got a fraction over a fraction. That's called a complex fraction. Usually, when I divide a fraction by another fraction, I can flip the denominator and multiply. But I can only do that if it's a single rational function. This is two different fractions. So I have to put these two fractions together first before I can flip it and multiply. What is this? Can I combine these two fractions?
Yeah. Isn't it just 1 minus x squared over 2?
It's x squared minus 1 over 2. Because they have the same denominator. So I can just operate on the numerator, which is x squared minus 1. Now that I have it as a single rational function, I can go ahead and flip it and multiply. So instead of dividing this by this, I'm going to multiply it by 2 over x squared minus 1. So the problem has now become this.
Okay.
Multiplying fractions is much easier than adding them. You multiply the numerators and you multiply the denominators.
Okay.
And again, there's no need to multiply that out. And also, I cannot simplify any further. I cannot do anything with this x squared and this x squared because this x squared has something being subtracted from it. If this were just x squared, I could cancel them out. But it's x squared minus 1. All right. Number 8. Same thing. I got a fraction divided by a fraction. Now, in this one, I actually can do exactly what I said, which is flip the denominator and multiply. I do not need to combine these two numbers up here yet. I may at the end, but I don't need to yet. In other words, it's not the same problem as the last problem. I'm not going to combine these two yet. There's no need to. So all I'm going to do is multiply it by 5 halves.
Okay.
Okay? Now, I do have to distribute it. So I end up with 5u over 4. I multiply 5 halves times this, and I add it to 125 over 8. Multiply this by this. Now that I have this, I do need to find a common denominator to add those. What's the common denominator between these two?
8.
Correct. Notice that I didn't have to multiply the two. I don't use 32. 32 would be a common denominator, but it's not the lowest, and it makes me use bigger numbers unnecessarily. So what's the top look like?
10u plus 125.
Okay. And I'm comfortable with that. Now, do notice something on this answer. I can change this into two partial fractions. I can make it this plus this. In other words, I have this kind of situation. A plus B over C is equal to A over C plus B over C. However, make sure you don't make the following mistake. A over B plus C is not equal to A over B plus A over C. Do you see the difference? You need a single entity in the denominator in order to split it up. So we do have that here. So it might be worth splitting it up. It's questionable as to what represents a total simplification here. There is some advantages in splitting it up, as you'll see here in a second. Well, 10u over 8 is the same as 5u over 4. And 8 doesn't divide evenly into that, so I'll just have to go with 125 eighths there. So that could be my final answer, but this also could be a final answer. Either one of them. I'm not sure the one on the right is really more simplified than the one on the left.
Yeah, I don't think it is.
Okay. Kind of depends on what your teacher is looking for there. Okay, so remember to check for extraneous solutions. Okay, now we're going to solve some equations. And this is always different than simplifying. The first thing you want to do to solve these is see if factoring helps. So, and always see if you can factor anything and make it better. Well, I can certainly factor this denominator into what?
N plus 2.5.
No, n plus 5 times n.
Oh.
This entity right there factors into this. Why do I factor it into that? Because I see another n plus 5 over here and an n plus 5 there.
Okay.
So it's going to be useful to have this in factored. Now, whenever we have an equation that has 3 denominators, there's an easier way to do it than what we would normally do. What we would normally do would be to find a common denominator for those two and add them together, right?
Mm-hmm.
Then we would do some sort of a cross multiplication to solve the problem. But we've got 3 denominators here, and not only that, but I can find something that I can multiply every term in this equation by and get rid of all 3 denominators at once. Now, this is not the same thing as multiplying the top and bottom by the same. That's multiplying a fraction by the number 1, which is what we've been doing this whole session. This is different. I'm going to multiply every term in the equation by this thing, this denominator right here, because it will get rid of all denominators at once. So I'm going to multiply everything by n times n plus 5. I'm going to multiply this term by that. I'm going to multiply this term by that. And I'm going to multiply this term by that. And notice the difference. I'm not multiplying these things by 1. I'm multiplying every term. I'm employing the strategy that I can do whatever I want to the left side of this equation as long as I do it to the right side. Mm-hmm. And that's what I've done. And I've realized that if I multiply every term by this denominator, I will get rid of all the denominators at once. Mm-hmm. Notice that on the left, this n plus 5 cancels with that n plus 5. Mm-hmm. In the middle, this n times n plus 5 cancels with this n times n plus 5. And there should have been a parentheses around here like that, okay? And over here, this n plus 5 cancels with that. So now I've simplified the equation considerably. I've got 6n on the left. I've got n plus 6 there. And I've got n there. Okay? Now I can solve it real easily. Subtract 2n from both sides, and n is equal to 6 over 4 or 3 over 2. And I only came up with one solution, so I don't have to consider extraneous solutions on this problem. Okay, so whenever you see an equation like that, if you can find something to multiply every term by that gets rid of all 3 denominators in one step, that's by far the best way to go.
Okay.
Number 10 is a similar case. Just doesn't look like it. What can I multiply every term in this equation by to get rid of all my denominators?
M.
Okay, so that leaves, so I'm going to multiply the left side of the equation by m. I'm going to multiply this term by m and this term by m. So now I'm left with 1 over there equals 4m plus 7. 4m equals minus 6. M equals minus 3/2. And notice that I could have added this 4 and the 7 over m instead, but I love this technique where I can multiply every term in the equation by something and get rid of all the denominators at one time. That's a very useful technique. Okay. I can see that this got a 2p in its denominator, this has got a 2p in its denominator. So let's factor out a 2p over here. What's that leave me with?
Negative 4,
What's here? When I factor out a 2p, I divide both. I divide both of these terms by 2p. That's what it means to factor out a 2p. I'm going to divide 2p squared by 2p, and I'm left with p.
Oh, okay.
Okay, and when I divide 4p by 2p, I'm left with 2. So that's how I factor. Now I've got minus 7 over 2p equals 1 over 2p. So now what do I want to multiply every term in this equation by?
2p again.
Not by 2p, because that won't be by this whole thing.
Oh.
Notice that I've got to get rid of this denominator on this term here also. My goal here is to get rid of the denominators. I want to get rid of this 2p, and this 2p times p minus 2. So I'm going to multiply everything by this denominator.
Okay.
What's that leave me with instead of this fraction?
1.
Okay. What's it leave me with here?
7, and then in parentheses, p minus 2.
Okay. And over here on the right?
P minus 2.
Okay. Notice how much easier the equation is now to solve.
Yeah.
In one step, we went from something that looks really complicated to something that looks really easy.
Mm-hmm.
Okay, so help me finish this.
So it's 1 minus 7p plus 2 equals 2 minus p, and then
now you just want to gather all your terms with...
Yeah.
Okay.
So you just subtract 1 from the left side.
Well, the way I like to think about it is I'm going to move a p over to here, giving me minus 8p.
Mm-hmm.
And I'm going to move all the numbers to the other side. Well, I've got a 1 and a 2. That makes 3. I move it to the other side. I got minus 5. Because I still got this minus 2 over there. So p is equal to positive 5/8.
Okay.
Every time the snow falls off the roof, my dog thinks somebody's at their front door. Hi, come here. Hold on one second, Morgan. See anybody out there? Yeah, there is. Sure, there was somebody there this time. I can tell the difference in the bars. Okay. Okay, 12, what are we going to do? How are we going to solve 12?
Multiply, or find the least common denominator of x plus 1.
No. That's not going to be the easiest way to do it. Let's just multiply every term in the equation by x plus 1.
Okay.
You see why? It gets rid of both denominators at the same time.
Yeah.
So what's the left become?
X plus 1.
No, I'm going to multiply this by x plus 1.
So
So
1.
here's what I'm going to do. Here's what I'm going to do. I'm going to multiply this term by x plus 1. I'm going to multiply the 1 by x plus 1. And I'm going to multiply the right side by x plus 1. I'm allowed to do that because I can do anything I want to the left side of the equation as long as I do it to the right. This is not the same as adding fractions. This is solving equations by doing the same to the left as you do to the right. The beauty of this is that cancels with that, leaves me with a 1 plus x plus 1 equals 2. How much easier can you get? Now x equals 0.
Okay.
Okay, interesting. There were no extraneous solutions on any of those. And in fact, there was only one solution on each one. It wasn't like we had two solutions on anything. All right, so you're getting into conics. Okay, well.
Or maybe could we skip these next 4, because I kind of know how to do those, and go to the I sent you another page and see if we can maybe try to do like one of the graphing ones.
Sure, absolutely. Oh. Okay. I presume they want you to graph these based on translations and shifts and all of that?
Yeah, or based on the vertex, focus, and directrix.
Oh, okay. So we have y equals minus 2x squared. What's your formula for vertex? How do you find the vertex?
Isn't it? Let's look at vertex. Oh, I think right now we're just doing vertexes that are
Okay, so how do you find the
or
vertex?
0, 0.
Uh-huh. Vertex is minus b over 2a.
Oh.
Gives you the x-coordinate of the vertex. You've learned that, right?
Yeah.
Okay. What's b in this case?
0.
Correct. So it's minus 0 over 2, and what's a?
Negative 2.
So the x-coordinate of the vertex is 0. What's the y-coordinate of the vertex, and how do we find it?
Oh, is it negative 4?
No, we plug in the x-coordinate into the original equation and figure out what y is.
Oh, so negative 2.
No, if I plug in 0 for x, y is 0. Negative 2 multiplied by 0 squared is 0.
Right?
Okay? So 0, 0 is our vertex. So I know that the vertex is right there.
Mm-hmm.
The focus doesn't really help you to graph it, nor does the directrix. But what does help us to graph it is to see this -2. What's the consequences of the negative sign?
It's going to be...
It's a reflection about which axis?
Oh. Is it the Y or the X?
The X. In other words, if I didn't have this -2, it would be a normal looking parabola like this.
Mm-hmm.
Okay, whereas if X had a value here, there's the Y value. If X had a value here, there's the Y value. But now we're saying that everything is going to have a minus sign in front of it, so it has to be this.
Mm-hmm.
Because now, whatever the Y value was going to be, I'm going to multiply it by a -2, and it's going to be on the other side of the axis. And in fact, so the negative sign acts as a reflection over the x-axis, and the 2 makes it skinnier. So instead of the normal wide parabola, you would have twice as skinny, like that.
Okay.
Okay? I'm going to have to run, Morgan. I have another appointment I got to get to at 5.
Oh, okay.
But hopefully that will have helped. Let me just take a quick look at some of these others here, see if anything looks strange. Okay. X equal 2y squared is a parabola, but it's a sideways parabola.
Right.
In other words, if I wanted to plot this, that looks like that. Only that's the vertex. It's at 0, 0 again. Your focus is going to be some distance inside the parabola like that. And the directrix is whatever this distance is, the directrix is the same amount on the other side and perpendicular to the line of symmetry. The line of symmetry through the sideways parabola is that. The directrix is always perpendicular to the line of symmetry of your parabola.
Okay.
Okay?
All right.
Well, let's end the session there.
Okay, thank you.
You're welcome. Hopefully that will have helped you. I will talk to you next time, Morgan.
Okay, bye.
Bye-bye.